Morning students, this is the class for 10th standard science subject. In physics our first lesson is laws of motion. Okay students, in last class we have seen what is mean by motion, then static, then the branch of mechanics. Okay, so now we are going to see about the force and motion. Okay students, in the case of your motion, one scientist has explained this phenomena. Okay, he is Aristotle. Okay, so Aristotle is a Greek philosopher and scientist. He explained this phenomena. Okay students, he stated that the natural state of earthly bodies is rest. Okay students, he stated according to Aristotle, the natural state of the earthly bodies is rest. Okay, not in motion, that means movement. Okay students, so according to Aristotle the motion is divided into two categories. One is natural motion, another one is violent motion. Okay, in the case of a natural motion, a moving body naturally comes to rest without any external influence of the force. That means எந்த விதமான எக்ஸ்டர்னல் இன்ஃப்ளூயன்ஸும் இல்லாமல் தானாகவே என்ன செய்யும் அப்படின்னா it will be comes to rest. That is, a moving body naturally comes to rest without any external influence of the force. Without any external means ourselves. Okay, so in this case the force is no needed. Okay, in this case the force is no needed. So it becomes a force independent motions. Okay, so force is no need அப்படின்றனால என்ன சொல்லலாம், natural motion is otherwise called as force independent motion. Okay, force independent motion. Whereas in the case of violent motion, a force is needed to make a process or to continue in the process. A force is needed, so that the violent motion is called as force dependent motion. Okay, because here a force is needed. Okay, so that the violent motion is called as force dependent motion. Move on to the next topic. Okay students, that is Galileo's concepts. Here some concepts are given by Galileo, so it called as Galileo's concepts. In first one is the natural state of all earthly bodies is either the state of rest. Okay, state of rest or uniform motion. Uniform motions means same motion. Okay, same movement. Already you know motion means movement, uniform means same. Okay students, then second one is the body in motion will continue to be in the same direction. Okay, as long as no external force is applied. That means எந்த விதமான external force apply பண்ணாத வரைக்கும் the body will be in continuous motion. Okay, that will continue the motion, that means movement. Okay students, then third one is inertia. Inertia means one type of force. So the inertia is nothing but one type of force, that is force inertia are interrelated term. Okay students, inertia means one type of force, these both are interrelated terms. Then what is mean by inertia means force is applied on your body to resist. When your force is applied on your body, at that time it resist means stop. Okay students, resist means stop. So when your force is applied on your body, on that time it resists its change in state. அதோட ஸ்டேட்டில் ஏற்படக்கூடிய அந்த மாற்றத்தை என்ன செய்யுமா, அதை தடுக்கும், ரெசிஸ்ட் பண்ணும். Okay, so that type of force is called as inertia. Okay, so inertia means what? The inherent property of your body to resist its change of state. Okay, to resist its change of state is known as inertia. Okay students, and then move on to the next topic, that is types of inertia. Okay, there are three types of inertia. First one is inertia of rest. Second one is inertia of motion, and third one is inertia of direction. Okay, inertia of rest, inertia of motion, inertia of direction. Okay students, so in the case of inertia of rest, the resistance of your body to change its state of rest. In the case of inertia of rest, the resistance of your body to change its state of rest. அதாவது ரெஸ்ட் பொசிஷன்ல இருந்து என்ன செய்யும், அது சேஞ்ச் ஆகக்கூடிய அந்த டைமிங் தான் நம்ம என்ன சொல்லணும், inertia of rest. Okay students, to change its state of rest, that is the key point in this case. Okay students, then next one is inertia of motion. Motion means what? Movement. Okay students, so here the resistance of your body to change its state of motion. So movingல இருக்கக்கூடிய ஒன்று என்ன செய்யணும், it comes to rest rest position கொண்டுட்டு வரதுக்கான இதுதான் என்னது inertia of motion. Okay, so to change its state of motion, okay students. Then third one is inertia of direction, that is here the direction is change. Okay, here the direction is change. For example, when a car is traveling in the north to side means next south to north. Okay students, so the movement is changed here in the case of your inertia of direction. Okay, so the resistance of your body to change its direction of motion, is nothing but inertia of direction. Okay students, then we have to see the examples of these three types. Okay, so first one is inertia of rest. For example, when you vigorously shake the branches of a tree, at that time what happens students? Some of the leaves and fruits are discharged from the tree and fall down. Okay students, so that is the example of inertia of rest. That is என்ன செய்றோம், ஒரு ரெஸ்ட் பொசிஷன்ல இருக்கக்கூடிய ஒரு ஆப்ஜெக்ட்டை நம்ம மூவ் பண்ணும்போது some of the flowers, okay, and leaves are fall down. Okay, so that is inertia of rest. Okay students, then second one is inertia of motion. The example for this phenomena is an athlete run. Okay, when athlete runs before some distance, because this helps him to jump higher and longer. ஏன் அவங்க வந்து some distance வந்து வாக் பண்ணுவாங்க அப்படின்னா அவங்களுக்கு நல்ல குதிக்கிறதுக்கு ஜம்ப் பண்ணுறதுக்கு நல்ல ஹையர் அண்ட் லாங்கராக அவங்க ஜம்ப் பண்ணுறதுக்கு it will be helped. Okay, then third type is inertia of direction. So example for this is when you are traveling in a sharp turn while driving a car means you can lead to sideways. Okay, ஒரு நம்ம என்ன சொல்கிறோம் அப்படின்னா ஒரு பெரிய வளைவு. ஃபார் எக்ஸாம்பிள் இந்த கொடைக்கானல் ஊட்டி இந்த மாதிரிலாம் காரில் போகும்போது நம்ம என்ன பண்ணுறோம், ஒரு ஷார்ப் டேர்ன் வந்து கிராஸ் பண்ணுறோம் அப்படின்னா என்ன செய்யலாம், நம்ம வந்து லைட்டாக சைடில் போயிட்டு இது வர மாதிரி ஃபீல் பண்ணுவோம். ஓகேவா, ஸோ தட் இஸ் த எக்ஸாம்பிள் ஃபார் inertia of direction. Okay students, the next our topic is linear momentum. Why this linear momentum is needed means if the mass and velocity of your body is more means if the mass and velocity of your body or object is more means at that time the impact of your force is also more. Okay, what is that? Impact of your force. Impact of your force is more. So we have to find the impact of your force means we have to introduce one new physical quantity. Okay, we have to introduce one physical quantity. That quantity is called as, okay, that physical quantity is called as linear momentum. Okay, what is that? Linear momentum. Linear momentum is denoted as capital P. Okay students, linear momentum is denoted as capital P. Okay, so linear momentum means it's the product of mass and velocity. Okay, it's the product of mass and velocity. Okay students, linear momentum is defined as the product of mass and velocity. The SI unit of linear momentum is kilogram into meter per second. How students? Because the SI unit for mass is kilogram and velocity is meter per second, so that the SI unit of linear momentum is kilogram meter per second. Okay, then next our already we know that 4 types of unit. You have already studied in your 9th standard class. Okay, what are the 4 types of units? SI units, CGS unit, MKS unit and FPS unit. Okay, so out of these 4 units, first we have to see these 2 units, that is SI units and CGS unit. Okay, so in CGS unit the linear momentum unit is gram centimeter per second. Okay students, gram centimeter per second. Here the linear momentum is a vector quantity. Okay students, here the linear momentum is a vector quantity because here the velocity is vector quantity. You already know acceleration, then velocity, distance are the vector quantity because the vector quantity has both magnitude and direction. Magnitude means what students? You know, magnitude means it has a numerical value starting from 0 to up to infinitive. Okay, so vector quantity means it has both magnitude and direction. Direction means in what direction it has to be traveled, from north to south or east to west. Okay, so the velocity is a vector quantity, so it has both magnitude and direction. So it depends on linear momentum. It also has a numerical value and direction. So the linear momentum is also a vector quantity. Mass is a scalar quantity. Okay students, so we don't put a vector on the upper side. Only velocity and linear momentum are the vector quantity. Okay students, here one problem is there students. Okay, by using of the linear momentum phenomena we have to do one problem. Okay students, what is that means? Calculate the velocity of your moving body. Okay, calculate the velocity. So we have to find what is the velocity. Okay, what is the velocity of your moving body of mass 5 kilogram. What is the mass? Mass of 5 kilogram, whose linear momentum is 25 kilogram meter per second. Okay, whose linear momentum, mass is 5 kilogram and linear momentum is 25 kilogram meter per second. Okay students, we have to find the velocity of a moving body. Okay, another two quantities are already given in the problem. Okay students, so first what is solution means, here we have mass and linear momentum quantity. Okay students, so what is the mass of your moving body? 5 kilogram. What is the linear momentum of your moving body? That is 25 kilogram meter per second. Okay students, so we have to find velocity of your moving body. We know that what is the formula for linear momentum? What is the formula for linear momentum? That is P is equal to m into v. Okay students, P is equal to m into v, mass and velocity. The product of mass and velocity are the linear momentum. Okay students, so from this we have to find the formula for velocity. Okay students, so mass and velocities are, you put in left hand side, the linear momentum is move on to the right side. What we have to find? We have to find the velocity quantity alone. Okay students, so from this v is equal to P divided by, okay, from this v is equal to P divided by m. Already we know what is the linear momentum. Its value is 25 kilogram meter per second. Okay, so we have to put instead of P 25, that is divided by, what is the mass of your moving body? That is 5 kilograms. So we have to put 5. So 1 5s are 5, 5 5s are 25. So the velocity of your moving body is 5 meter per second. Okay students, how meter per second? Because the velocity is nothing but displacement by time. Okay students, velocity is nothing but displacement by time. So the SI unit for distance is meter and time is second. So the SI unit for velocity is meter per second. Okay students, thank you.